Now, naively, what we would expect is that as we stick more and more electrons onto an atom, we expect that the atom is going to get bigger, right? I mean, that's pretty reasonable. We have more particles around a nucleus, and so we should have a wider radius. We're going to find out in separate videos that that's not going to actually happen. And there's a surprising effect for you right there. Well, let's take a look at why. And it all comes back to our inner electrons and our shielding forces. Now, let's start out by looking at hydrogen. Hydrogen is our simplest atom. It's got one proton, and when neutral, it's got one electron. That electron will be in the 1s orbital. And this is telling us that we have one in the 1s orbital. We get to helium. We now have two protons, meaning when it's neutral, it'll have two electrons. Those two electrons are both going to be in 1s orbitals, so the 1s orbital will now have two electrons in it. Well, let's think about what the effective nuclear charge is going to be in these. In these cases, effective nuclear charge, as this one electron looks inward, there's no electrons in the way. It'll see all +1. Same thing with this helium. As it looks inward, it's going to see all +2. When you get up to the next shell, lithium, as you look inward, it's going to look a lot like helium in the sense that it's going to have all of its plus charges in the center. It's going to have a shell of 2 electrons around that. But then there's going to be this additional electron that it just picked up by having the third proton. And we're going to have a 1 electron area sitting out here. So as it's looking inward, it has 3 plus charges in lithium, +3, -2. It's going to give you a +1 effective nuclear charge. So we're going to have a Z effective of 1 and an electron out here that's looking at that. But look what's going to happen if we jump to beryllium. And we'll just do that one, and then I'll maybe point at neon just to really emphasize things here in a moment. What's going to happen when we build that one? Well, let me get rid of this for a moment. Remember, the inside still looks the same, right? We still have the 2 electrons that we had building up past helium. We have that 1 electron from lithium and 1 more from beryllium. As we look inward, we're now up to a +4 charge in the center. So now we'll just make it look even bigger. There we go. A bigger +4 charge in the center. We have 2 electrons, meaning the effective nuclear charge is now Z effective equals 2. And we're going to have an electron over here, and I don't know, maybe an electron over here. Now notice, these two aren't in each other's way when it comes to seeing the positive charge. And this is when they're about as close as we'd expect them to get. If I put them onto the opposite sides, they're really not going to see each other. And they're certainly not going to be blocking their view of the positive charge. That means, despite now having more electrons, this electron is seeing a +2 effective nuclear charge. I'm expecting, if I have a +2 charge, that the minus charge is going to be pulled in tighter, right? So I'm expecting that the radius is actually probably going to drop as I come all the way across my period. That's really kind of a surprising idea. It's the opposite of what we expected without thinking through it carefully and thinking about the particles. As we add electrons across, we actually made the atom smaller because we also increased the number of protons, and since all the inner shell electrons stayed where they were and didn't increase the number, the effective increases as you come across, tugging your electrons in tighter. It's kind of a neat effect. Now, to really emphasize it all the way, let's look at neon. Well, from what I just described, I'd expect neon to be a very small atom, right? Well, now, we thought we had a big plus charge in the center before. It has gotten dramatically larger now, because that plus charge is now up to +10. I still have 2 inner shell electrons. That means as I look inward, my effective nuclear charge will be +8. I'm going to have my 8 outer shell electrons in all of their orbits. I can't really draw that in 3 dimensions, so I'll just space them out kind of evenly. But remember, they are in orbitals. They each look inward. This electron is not in the way of that electron, let alone in the way of this one. They all are now experiencing a +8 charge instead of a +1 charge. So they're all tugged very tightly in. So I'd expect lithium is probably a reasonably large atom, and certainly large compared to something like neon. That's one of the effects that we're going to see when we talk about inner electrons and shielding. That'll come up as a very important thing when we think through atomic properties and periodic trends.